All right, so this is 7.1a part 2. So same thing as we've already been doing, we just have some more factoring to do. So I have to factor the x squared plus 5x minus 36, and we would use our diamond on that. So if I do my diamond there, my multiplication is negative 36 and my addition is 5. If we go through and list all the numbers that multiply to be 36, you have 1 and 36, 2 and 18. After 2, we have 3 times 12. And then you have 4 times 9. And I can stop there because 4 and 9 make 5. So we have 4 and 9. Since 5 is positive, that means 4 needs to be negative because our larger number has to be positive. So 9 minus 4 is 5, and 9 times negative 4 is negative 36. So my factor here will be x minus 4 and x plus 9. So my top is done, or my numerator. Then I go to the bottom. Hopefully you notice that this is a difference of squares. So that means where we factor and we split up our x's, we split up our 7's, and one gets a minus and one gets a plus. Times. And if you ever have something that's not a fraction, you can always put it over 1 to make it a fraction. They already made it for a fraction for you here. And then again, we're going to do our diamond. So we're finding what multiplies to be 28 and what adds to be 11. If we go through, we have 1 and 28, 2 and 14, 3 doesn't work, and then we have 4 and 7. And 4 and 7 do make 11. And I forgot to put my negative there. So that's supposed to be a negative 11. So both of these will have to be negative in order for them to add to be negative 11 and multiply to be positive 28. So then I have it as x minus 4 times x minus 7. So if you look through here, x minus 7's are the same, so I can cancel those. I also have x minus 4's are the same, but you have to have one on the top and one on the bottom in order to cancel. So I can't cancel out the x minus 4's. But when I write my answer, instead of writing it twice, I'm just going to write that as x minus 4 squared, and then x plus 9, all over x plus 7. And nothing else can reduce, so that is my final answer. Okay, dividing is pretty much the same thing, except for you have to end up changing division into multiplication. And the way that you do that is by flipping the second fraction. A lot of you might have learned this at Rayburn by KFC. Keep, flip, change. I oftentimes say same, change, flip because first one's the same, change multiplication, flip it. So on this first example, if I rewrite the problem, the first one stays the same. We keep it the same. 5x squared, y cubed, all over x to the 7th. We change division to multiplication, and then we have to flip our second one. So I'm going to end up with y to the 3rd on the top and 30xy to the 4th in the denominator. Just like we did on our multiplication, I suggest you simplify your top and your bottom before you reduce. So if I go through and rewrite this, I have 5. On the top, I only have x squared. And then with the y's, I have 3 and another 3, and we add those together to make 6. In my denominator, I have a 30. I have x to the 7th and an x to the 1st, which makes x to the 8th, and then a y to the 4th. Now I would go ahead and simplify. When I do that, 5 goes into 30 6 times, so my denominator has a 6. Remember with these we subtract. 8 minus 2 is 6. Since 8 is on the bottom and it's larger, x to the 6th will be on the bottom. So these canceled and you're left with 6. With the y's, 6 minus 4 is 2, but I'm going to cancel the 4's out and the 2 will be left on the top because the larger number was on the top. And that is your final answer. All right, last example for 7.1a notes. This one kind of has a lot here. Instead of rewriting it, let's go ahead and factor and change and flip all at the same time just to save time. So on the first one, on 2, the numerator here, we have negative 27 as our multiplication, negative 6 is my adding. The numbers that multiply to be 27 are 1 and 27, and 3 and 9. So 3 and 9 can make 6. Since 6 is negative, we want 9 to be negative, and always double check, and those do multiply to be negative 27 and add to be negative 6. So when I write this out, I have x plus 3 times x minus 9. In my denominator, I would take out a GCF. GCF would be 2 and also x, because each of them have a 2 and each of them have at least one x. When I divide by 2x to both of these terms, I'm left with x plus 1. Now I'm going to go ahead and change my division sign to multiplication, and we need to flip this fraction. So x squared is going to go to the top, and then my denominator, I'm going to have to use my diamond. So 45 is my multiplication, negative 14 is my adding or subtracting number. So if I list my numbers that multiply to be 45, I have 1 and 45. Let's see here. 45 is 3 times 15. Sorry. And then 4 doesn't work, and then we have 5 times 9, and 5 times 9 is my numbers that work. So we have 5 and 9. In order for it to be a negative 14 and a positive 45, both of these have to be negatives. So those add to be negative 14 and multiply to be positive 45. So when I write my factors on the bottom, I have x minus 5 and an x minus 9. So now we just go through and see if there are any like terms that we can reduce. If you notice, the x minus 9s are the same. And I don't see any more parentheses are the same, but see how you have one x on the bottom and 2 on the top? I can go ahead and cancel out one of these x's for one of the x's up here. And it doesn't look like anything else reduces. Always, if you have something single like this, you bring it to the front. So we have x times x plus 3 over, and on the bottom I have a 2, and then an x plus 1, and an x minus 5. And you can always double check, and if you have to reduce more, you can. But in this case, you can't. So that is your final answer. And that's the end of 7.1a.